About the site 1, we have this information, and this means that for 192.168.10/24 and 11.0/24, the last router that registered these two for example address is the router 2. This is the last router. And about the site 2, the last router is the router 4. But if you want, you can see the detail show with the show Lisp site, for example 192.168.10/24. look at here. If you check the show Lisp site for one special for example, or a specific IP address, you can see that we received for the 192.168.10/24 from both router 2, okay, means XTR2, and also router 1. In the router 2, as you can see, quad 1, this is the, you know that this is non-local locator, because the XTR2 has only quad 2 as the RLOC. Because of that, the quad 1 is a non-local RLOC, and a state of this RLOC is up, and the priority is 1. This means that the XTR2 first sent 192.168.10/24 with the priority of 1 and weight of 100, okay, with the RLOC of the quad 1 to the MSMR1, and also with another statement is another map register is from the router 2 is 192.168.10/24 with the RLOC of quad 2 with the priority of 10. This means that the router 2 advertise itself, and also the RLOC of itself, and also RLOC of router 1 with different priorities. As you can see, the priority of router 1 is lower, and this means that the preference of the router 1 is higher. Also, as you can see here, we have similar information received from the router 1 about the 192.168.10/24 quad 1 local RLOC has the priority of 1, and quad 2 the non-local RLOC has the priority of 10. So easy, both of them are same. Okay, let me to show you the for 192.168.11.0. here we have reverse information. For example, router 2 advertised its RLOC quad 2, okay, with the priority of 1, and the router 1 RLOC with the priority of 10, and also the router 1 advertised its RLOC with the priority of 10, and the R2's RLOC or XTR2's RLOC with the priority of 1. It is okay. This means that both of them can emphasize that the router 1 has the higher preference for 192.168.10, and the router 2 has the higher preference for the 192.168.11.0. but both of them can be work as the secondary router for other networks. Okay, in the router 3 and router 4, we about the 192.168.20 and 22.0, we have the same condition. For example, show Lisp site 192.168.20 can show us that we received information from the router 3 and router 4. Router 3 said that quad 3 as the local RLOC has priority of 1 for 192.168.20, and quad 4 as the non-local RLOC has the priority of 10. Also, the router 4 advertised this information. Quad 3 as the non-local RLOC has the priority of 1, and quad 4 as the local RLOC has the priority of 10. So easy. Okay, now if you want, you can check the XTR1 map cache, show IP Lisp map cache. Okay, here as you can see, because we send traffic from VPC1 to VPC3, we need first to learn about the 192.168.20's for example RLOC, and as you can see, when the XTR1 asks from the router 9 or router 10 as to mapping resolver, it received this information that the quad for reaching to this IP address, to this EID, you can use quad 3 with the priority of 1 and quad 4 with the priority of 10. This means that the quad 3 has higher preference. Because of that, now as you can see, we are using the XTR3. This is working now. Okay, but in XTR2, look at here, in XTR2, if you check the show IP Lisp map cache, you can see that we learned about the 192.168.22.0/24, for example, prefix or EID. The RLOOK of quad 3 has the priority of 10. The RLOOK of quad 4 has the priority of 1, means the quad 4 is better. Because of that, as you can see, we send traffic from VPC1 and the traffic sent to the XTR1, okay? And after that, XTR1 now is using the router 3 as the entry point for 192.168.2.0. This means that the traffic engineering is working now. And also we send traffic from VPC2 to the XTR2, and XTR2 now is using the router 4 as the entry point for the quad 4. This means that everything is working good. If you want, you can check the XTR3 also. Show IP LISP map cache can show us that here for the 192.168.10/24 we are receiving quad 1 with the priority of 1 and quad 2 with the priority of 10. This means that we sent the traffic from the R1 to R3, and for response the R3 now is using the quad 1. Okay, but here we have another information for 192.168.11.0. The reason is that let me first check the XTR4. Look at here, in XTR4 we expect to have no information. Show IP LISP map cache. Look at here, we don't have information. Why? Let me to explain it. First, from VPC1 we send traffic to the XTR1 and the traffic encapsulated to the XTR3 and then to the VPC3. Then we receive the answer from VPC3 in XTR3. Then XTR3 encapsulate the traffic to XTR1 and then the traffic received to VPC1. First, let me to show you this procedure from let me to capture the ETH00, the ETH00 of the router 3. After that, let me to send traffic from the, for example, VPC1 to the 192.168.2.10. As you can see here, we have the ICMP echo request and echo reply. This means that both traffic now is transporting from the router 3 to the destination and from the router 3 to the source. Okay, but about the traffic of VPC2 and VPC4, now we have one mistake. Look, one problem. Let me to explain it. As you saw, I sent traffic from VPC2 to the VPC4 from the XTR2, okay? Because in XTR2 we have the show IP LISP map cache for 192.168.22.0, and as you can see, the priority of the router 4 is the quad 4 RLOOK is a higher priority. Because of that, we encapsulated the traffic to router 4, then the traffic received to the VPC4. Until here everything is good, but when the PC4 answered to the VPC2, because here we don't have any policy and this is only a load sharing, the traffic of VPC4 instead of the router 4 advertised to router 3. Because of that, the router 3 sent this traffic to router 2. It is not okay, because we expect to receive traffic from the XTR4, but this is not related to the LISP. Here you need to, for example, configure one policy-based routing or PBR for sending traffic of VPC4 to XTR4 and then to the XTR2. Let me to show you the capture again. This is the capture of the interface ETH00 of the router 4 here. If you send traffic from the VPC2 to the VPC4, you can see that here we don't have ICMP echo request, but we have ICMP echo reply. Why? Because the echo request is forwarded with the correct pass from the router 4 to the VPC4, but the reply is receiving from here. It is not related to LISP. Let me to solve it. From on the ETH03, we can configure a policy-based routing. We can configure this policy-based routing in router 6, for example here, conft, then for example route map A, okay, permit 10, set IP next hop 10464, the IPS of router 4. I'm going to assign this PBR to the ETH03, this route map, IP policy, then route map, IP policy, route map, then for example A. This means that if in ETH03 we are receiving a traffic, this traffic should forward to XTR4. That's it. Let me to show you the result. This is our capture, and again from VPC2 I'm going to send traffic to the 192.168.22.10. As you can see now, we have both ICMP echo request and reply, and in XTR4 also, if you want, you can check show IP LISP map cache. Now you have entries for 192.168.11.0. And as you can see now, we are using the Lisp for traffic engineering without using the BGP, and this is one of the other usage and other powers of the Lisp. Also, if you want, you can use some debug command for